In today's video, I would like to introduce a very nice problem of Baltic Way Mathematical Olympiad 1994. Here is the following setup. Is there an integer n such that we have this setup, square root of n minus 1 plus square root of n plus 1 is a rational number, okay? In the other word, we are going to prove this one is a rational number or not a rational number, okay? Try to use the absurd proof by assuming this one is a rational number, so at the end of the term you will find a contradiction, okay? So I will recommend to give the try to this problem prior getting to the solution. Go ahead, pause this video when you come back to see the full solution. By the way, don't forget to support us with your like and subscribe, okay? Without loss of generality, suppose we have this number, square root of n minus 1 plus square root of n plus 1 equals p over q as a positive rational number, with p, q and n are positive integers, with p and q are relatively prime. So this one must be reduced to the lowest fraction. If we have, for example, 4 over 6, we must have 2 over 3, okay? This one like p, this is like q. We must have like this, okay? Now we are going to work on this one, okay? This one will have q over p. We will have 1 over square root of n minus 1 plus square root of n plus 1. I'm going to rationalize this one by multiplying by conjugate. I will have in numerator square root of n plus 1 minus square root of n minus 1 over square root of n plus 1 minus square root of n minus 1 factor square root of n plus 1 plus square root of n plus 1, okay? By bringing this one down here, I will get q over p equals, I'm going to equals numerator, which is square root of n plus 1 minus square root of n minus 1. By distributing this denominator, I will get square and square root will be cancelled out each other. I will be left with n plus 1. We'll get n plus 1 minus, same thing with the second term, I will get minus n minus 1, okay? So I'm going to simplify the denominator. N will be cancelled out. I will be left with 1 minus minus 1, which is 2 in denominator. So I'm going to multiply side by side. I will get 2 times q over p equals to this term, which is square root of n plus 1 minus square root of n minus 1, okay? This is the second equation. I'm going to bring the first equation down here. So we'll have p over q equals square root of n minus 1 plus square root of n plus 1, okay? So now I have an equation system. So by adding first equation on second equation, I will get square root of n minus 1 cancelled out because one is positive, the other one is negative. I will be left with 2 times square root of n plus 1 equals these two terms. So this one equivalent. By adding this one on this one, I will get 2 times square root of n plus 1 equals this term plus this term, which is 2 times is multiplied by q over p plus p over q, okay? The next step, I'm going to divide both sides by number 2. If I'm going to divide both sides by number 2, this number 2 will be cancelled out. This one will be cancelled out. This one will have 2 in denominator underneath of this one, okay? So now I'm going to multiply side by side. I will get the same term, square root of n plus 1 equals 2q square plus p square in numerator. I will get 2 times pq in denominator, okay? Now I'm going to multiply side by side, and at the same time I'm going to square both sides, okay? So this one I will have 4 times p square q square is multiplied by n plus 1 because I have squared this one. The second term, I will have 4 q to the 4th plus 2 times these two terms, which is will have 4, is multiplied by p square q square plus p to the fourth. Okay, now I'm going to distribute this term here. I will get, by distributing this term here, I will get 4p square q square n plus 4p square q square equals 4q to the fourth plus 4p square q square plus p to the fourth. Okay, now I will get this term 4p square q square cancelled out because one from both sides. So I will be left with this term. I will be left with this one. I will have 4p square q square n equals 4 times q to the fourth plus p to the fourth. Okay, the left hand side of this equation is multiplied by a number 4. Okay, so that's mean this side is divisible by number 2. Okay, that's mean the right hand side of this equation must be divisible by 2 as well. This one is divisible by 2. This term must be divisible by 2 as well. Okay, so this one is telling us 2 must divide p, this one. In the other word, according to the divisibility statement, p you will have 2 times is multiplied by k, where is k is a some natural number. Okay, this is very important. I'm going to take this found fact and insert it in the same equation. So by replacing p with 2k, I will get here 2k square q square n equals 4q to the fourth plus 2k to the fourth. I'm going to simplify this one. I will get here 4 is multiplied by 4, which is 16. K square is multiplied by q square n equals 4q to the fourth plus 2 to the fourth, which is 16, k to the fourth. Okay, now I'm going to divide both sides by number 4. Okay, so this one equivalent 4 k square q square n equals q to the fourth plus 4q to the fourth. Okay, now we have ended with this expression again. This expression is similar to the first one, but this time I will have the similar job here. The left hand side of this equation is a multiple of number 4. That's mean the left hand side of this equation is divisible by number 2. So the right hand side of this equation must be divisible by 2 as well. This one is clear, is divisible by 2 because we have number 4 is multiplied by this one. This one also, which is q, must be divisible by number 2 as well. So this one is telling us 2 must divide q. Okay, so we have 2 terms here. We have 2 divides p and also we have 2 divides q. This one is telling us GCD of p and q equals number 2. Okay, which is contradiction. In order to have the fraction as rational number, we must have p and q are relatively primes, as we have in our assumption. What does mean contradiction? That's mean there is no n as an integer number makes this one as a rational number. This one is not a rational number. Okay, so I have done with this proof. If you are interested to watch this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.